Okay, so we are going to be moving on to chapter 7 and working on further functions. So we will be looking at 7a, which is more power functions from the Unit 3 and 4 Cambridge Methods textbook. So before we get started, I am just going to revise on all of the functions that we have currently looked at. So we have looked at f of x is equal to x to the power of n when n is positive and even. And it's always going to look like this. So the with x to the power of 4, it's a bit more flatter compared to a parabola, but it's still the same shape. The next graph that we've looked at is when our n is negative, and we have a inflection. So again, we've already dealt with these two. Then we're going to move on to x to the power of negative n. Now we have dealt with this, but we've never had it in this form, so I've rewritten it to being 1 over x squared for this graph, which is the same as x to the power of negative 2. So, and it's always going to have this shape as long as our n is positive here and even. Then finally, if it is odd, I'm just going to do 1 over x because 1 over x is the same as x to the power of negative 1, and we know it's going to be in quadrant 1 and quadrant 3. The, uh, the next one that we've done is looking at a square root function, but in the textbook it puts it as x to the power of a half or x to the power of 1 over n. So I've rewritten it in this form because I want us to be able to see that relationship and that when we have our n being positive and even, it is going to only be in quadrant 1. Whereas when we have a 1/3, we know that is, go back, that is the inverse of this graph right here, x to the power of 3, which is on the side here. So we already know this, but I'm writing it as the cube root of x, or I can say it as x to the power of 1 over 3. And we know that our n is positive, but it's odd. So that is what we have already covered. Now we are going to be looking at when we have our power as a negative and we've got 1 over n. So I've rewritten this because it's important that we see it in terms of a positive. So if I take that to the bottom, it's 1 over x to the power of 1 over n. And then I can write it as a square root. So 1 over this, the square root of x, and it could be a squared, it could be a cube root. So first thing that we're going to look at is if n is positive and even, then our domain is just going to be real numbers that are positive. If it is not and it is odd, then it's going to be in quadrant 1 and quadrant 3. And it'll be all real numbers except 0. The reason why it can't be 0 is because we can't have our denominator being 0, which is the reason why we have an asymptote. So we've got two asymptotes here of when x is 0 and when y equals 0. So let's have a look at a couple of these questions. So the first question that I'm going to deal with is f of x is equal to 4x to the power of negative 1/3 minus 2. So whenever we're thinking about the maximal domain and the range for these kind of questions, we need to go back to what is our basic function. So our basic function is x to the power of negative 1 over n, and the key part is n. N here is odd, which means it's all real numbers except for 0. And there's no horizontal shift, so it stays the same. Then for the range, we need to look at the vertical shift, which we've got minus 2 here. So we originally had a asymptote um, at y equals 0. That has changed to go down 2, which means we will have a range of all real numbers except for 2. If we are determining whether it is odd or even or neither, most of these graphs will be neither, but there will be some that you will find that are odd or even. So we've done this before. If it's even, we put a negative in, it's going to still stay the same graph. If it's odd, if we put a negative in, it will be whatever our y value was, f of x, it becomes negative. If I put it in, I simplified this as best as what I could, and it didn't turn out to either one of these, so I know it's neither. We've already set our asymptotes, so now we can graph. So the first thing I'm going to do is put my 2 asymptotes that I've stated, and I've written those equations here. The second part, I'm going to pick a value, so I always go 1 across. So if I pick x as 1, then I know that I will have 2. Again, if I pick -1, I get -6. So I've got my 2 points. It's not going through the y-axis, but it is going through the x-axis. So I need to find the intercept. So I make y 0. I add 2, and then I divide by 4, and I get a half. Now, this to get rid of the power of -1/3 and get x by itself, you need to do the opposite of this, or to get rid of this. So I'm just going to do a power of -3 on both sides. That just cancels this out because -1/3 times -3 equals 1. So that gets x by itself. And this over here, I didn't do all this working out, but I will do this. We know that this -3 applies to both of them, but it really can just be flipped. And then it becomes a positive. 1 to the power of 3 is 1, and 2 to the power of 3 is 8. So we've got x is equal to 8. I grabbed that point and put it here. I didn't extend my x-axis enough, and then I just draw my graph. Let's have another go here. Okay, so the first thing I'm going to do is for f of x is equal to 2x to the power of -1/4, take away 3. So I'm going to state the maximal domain. So again, we start off with what is our basic form. Our basic form is x to the power of -1/n. My n here is even. Even means my domain has to be all real numbers that are positive. There's no horizontal shift there, so it's not going to change. So it stays as all real numbers that are positive. Then I go on to stating the range. So the range here again, I think about this graph is just going to be in quadrant 1, but I have a shift here, a vertical shift of 3 units down. So that means I go 3 units down from 0 and I get to -3, but there'll be an asymptote there. So it can't equal to -3 to infinity. To determine if it's odd, even, or neither, I have to plug -x into my equation. And I can't get it to either one of these equations, so it's neither. We've stated already, we've got an asymptote at 0 and an asymptote at -3. So now we can graph. I grab my 2 equations and plug them on for my asymptotes and make sure I've labeled my 2 equations. So we know it's just going to be in this quadrant here. So I'm just needing 1 point. So I'm going to pick 1 and substitute x as 1 into my equation, and that's going to give me -1. Then from this, I need to find the x-intercept. I don't care about y-intercept because I've got an asymptote there. So I make y equals 0. I add 3 and divide by 2. Because I've got to the power of -1/4, I'm going to put to the power of -4 on both sides. That cancels this out and leaves me with x. And this flips this equation to 2/3, and it turns into 2 over 3, but each one has got to the power of 4. So that gives me 16 over 81. Now, I put that into the calculator to get a decimal so I can accurately put it on my graph, and I got 0.198. I did round this. Finally, I can draw my graph. The last part we are going to look at is when we are dealing with a function of x to the power of p over q, where p and q are both positive integers. Now, we do need to look at it in terms of understanding that my domain, if q is odd, domain is all real numbers. If q is even, domain is x is equal to or greater than 0. My range, if p is even, my range will be equal to 0 or to infinity, or if it's odd, my range will be all real numbers. So I'm just going to get up Desmos. Now, Desmos is a really good tool for us to use. I'm just going to put a small on here so I can keep those relationships and talk about it. So let's just focus on my domain. It says if Q is odd, domain is all real numbers. So Q is odd here. So it doesn't matter what I put here. 2, 3, 4, it's all real numbers. I can change this to 5, 7. We can see that the domain is all real numbers. If it's even, so I will now change it to even, make it 6. We can see it's equal to 0 and greater. I can change it to 8 and 10. So there's the pattern that we need to use. Now, the more you do a lot of these graphs, the more you will be able to do it without a calculator and see the patterns. But for these, we need to understand the domain and range, but you will be able to use the CAS calculator to help you graph. So likewise, if I look at my range now, so range is we're focusing on our p-value. So if p is even, so let's make p 6. My range is going to be from 0 to infinity. So I put p equals 6 here, but it's not showing my range is being 0 to infinity. And there's a reason why. I'm just going to now lose this for a minute so I can write on the screen. Actually, I'll do it here. So we know if I have 6 over 10, that is 0.6, but that is also the same as saying 3 over 5. So that means I've said that my bottom number, my denominator, is actually an odd number, and an odd means range is all real numbers, which this is showing. So for me to check this, I need to be careful what I've got here. So I'm just going to change my Q to 2 for a minute. So now for my p-value, if I put it as 6, so I changed Q to 3. So if I put P as 6, what you're going to notice is it is even. If I change this to P being 2, again, 2 is even. And straight away I can see that it's in starting at 0 and going all the way through to infinity. I can put 4 and it's going to be the same. So it's just being mindful that there is some relationship between both of these that we do need to use.